Okay, I'm looking at question 3 now. This is quite a common sort of question that comes up. I'm also going to show you on the side a little bit of notation that happens. So we're starting off with the number of bees at the start of the study is 30,000. After 3 years, the study has found there's 34,000. They've got a model that predicts the bills. They will increase at a rate of P% per year. Now, if you think back to compound interest you'll have done, then the total amount of money is equal to the principal multiplied by 1 plus the interest over 100 to the power of time. That's the formula basically we're using. So we're talking about the number of bees is equal to 30,000 is the normal number. That's what we started with, and we're increasing at a rate of P% a year. So if we say that P, 1 plus P over 100 is a rate, I can simplify my expression to being R, the growth rate, to the power of t. This form of equation you'll often see written as n0, and then some power, often in terms of e to a constant times t. This is quite common in growth models, both physics and biology, this sort of notation. That's just an aside. So let's solve the problem then. Find the value, giving 2 decimal places, the percentage. So we have 34,000 coming out is 30,000 r cubed. So 1 times 3. R cubed is 34 over 30. Take the cube root. 17 over 15 is the simplified version. And that gives me a number. So I need the calculator for a minute. Let's get it out of the way. Where's the calculator? Gives me value of R of 1.04260. So that my percentage then is the 4.26. Okay, so that's how you can calculate it, and that's to 2 decimal places that they requested. According to the model, at the end of a period of time, the colony exceeds 75,000. So part A was that one. Part B, we've now got our R value. So we've got N is 30,000 multiplied by 1.0426 to the power of T. And we would like to actually rearrange this so that we can say 75,000 is equal to something 1.0426 to the power of T over 30,000. Now, solving these problems, in the past you might have been encouraged to do trial and improvement. We now know about logarithms, and the beauty with logarithms is if I take the log of the left hand side, I'm going to use ln this time, it doesn't matter. It could be log base 10 or log to any base you can do, or ln, and I'm going to choose ln. It's quite common to use ln when you can. 30 into 75 goes 2.5 is equal to the ln of 1.0426 to the t, which is t using the power rule, is ln 1.0426. So t is what happens when you do the division of them two. And it's greater than or equal to, because we want the minimum time in years. Then, oh, in years of study, they said, not T. So my use of N up here would need changing. So in terms of what they're asking for, I need to say how many years, and this is minimum time in years. The numbers they've crossed over, and I'm not happy about using this N because this is a common use for N. So N is greater than or equal to the log of 2.5 over the log of 1.0426. And chuck that into a calculator. N has got to be greater than or equal to 21.96. And if N is an integer, N is 22 years. Okay, and that's the integer value.